We are on page 3 of the packet. This is problems. These are problems 5 and 6. So this says the function a of t is shown as the acceleration of a particle which has an initial velocity of 50 meters per second. So I like to write out what that means. That means v of 0, when time is 0, when you input 0, you get an output of 50 meters per second. The areas are as follows. So A is, now it says A is 30, but take note that A is negative. So I'm going to write negative 30 right there. B is 80, that is positive. And C is 20, but again, negative 20 because it's below the x-axis. And this is A of t, and time is in seconds. What was the particle's velocity at t equals 20? So use fundamental theorem. You can start at v of 0 because we have that information. We can add the change in velocity from 0 to 20 of a of t dt, and that would land us at v of 20. And we have that information. 20 is here, so this is going to be v of 0 is 50. And so what is the change in velocity here? So it's minus 30 plus 80 minus 20. That lands us at v of 20. So v of 20 is equal to 50 minus 30 is 20. 20 plus 80 is 100. 100 minus 20 is 80, and I will label velocity as meters per second. During what times was the particle slowing down? So slowing down is talking about speed. We're talking about speed decreasing. So what does slowing down mean? It's when the velocity and the acceleration have different signs. So we're looking for, okay, acceleration is negative on the 0 to 5 interval, right? These are all negative values here. Acceleration is negative. What about velocity, though? So is the velocity positive or negative on that interval? So if we look at this, we could say, well, the velocity was starting at 50 meters per second, right? So the velocity at 0 is positive. And we can come up with some here. Let me make a little chart here. So v of 0, actually, let's build off of this. V of 0 is 50. So what would v of 5 be? 50 minus 30 is still 20, right? Let me show the math on that. 50 minus 30 is still 20. So the velocity is going to go from 50 to 20, so it's going to stay positive. So on the 0 to 30, a of t is less than 0, but v of t is greater than 0. So that's going to be positive. So during what times is the particle slowing down? Because they disagree there. I'm going to say for 0 less than t less than 5, speed decreasing, because a of t is less than 0 and v of t is greater than 0. Okay, does that happen again? So what is v of the next change is at 15? So we're at 20. We're going to add 80 to that. So we're sitting at 100 meters per second. So velocity is still positive on this interval. And acceleration, these acceleration values are also positive. So the particle's speeding up here, so not on that interval. Let's look at v of 20. So we're sitting at 100, and we're supposed to subtract 20. Gets us to 80 meters per second. So the velocity is going to stay positive there. So in this section, a of t is back to being negative, but velocity we just figured out was still positive on that interval. So also for 15, for times between 15 and 20, the speed is decreasing because a of t is less than 0 and v of t is greater than 0. What was the particle's maximum velocity, and at what time was it at that velocity? So this is kind of helpful that I did all that work before because I just listed all my possible extremes, right? So max velocity happens at 15 seconds when we hit 100 meters per second. So max velocity, it asks for both parts. Max velocity equals 100 meters per second at t equals 15 seconds. I'm going to write seconds so that doesn't look like another 5. Okay. What was the particle's minimum velocity and at what time? So again, referring to my chart here, The lowest velocity number I have is 20, and that happens at 5 seconds. So minimum velocity is 20 meters per second at t equals, what did I just say? That was at t equals 5 seconds. All right, moving on to problem 6. A particle travels along the y-axis so that its velocity at time t is given by this equation for anything greater than or equal to 4 seconds. That's so that you don't get negatives under there. V of t is in feet per second. If y of 4 equals 3, find y of 5. So set up fundamental theorem. That's y of 4 plus the change in position from 4 to 5, excuse me, of v of t dt is equal to y of 5. And let's not use a calculator for this one. We could do a calculator, but this is also could be non-calculator. We need to practice our u sub. All right, so what was y of 4? Y of 4 was given to us as 3 plus, I need to set up this integral. Actually, let me take my work over here. Okay, so 3 plus the integral from 4 to 5 of, so it's t times the square root of t squared minus 16 dt. All right, so let's do a bit of u sub. We'll do that kind of off to the side here. So I'm going to let u equal t squared minus 16. Du dt will then equal 2t. You can solve this for dt by dividing 2t over to this side, multiplying dt over here. Right, and then we can say, all right, so we're going to sub in what we have. Oh, let's change our bounds too. So instead of 5, let's make u equal to 25 minus 16. What's 25 minus 16? That's 9, right? And instead of 4, we will let u equal 4 squared minus 16, so 0. So now what do we have? We have 3 plus the integral from 0 to 9 of, all right, t is going to cancel out. Square root of u, dt is going to be du over 2t. So yep, these t's cancel, so u sub worked. Let's take the 1/2 out in front. Integral from 0 to 9 of, 1/2 out in front of u to the 1/2 du. And then we can integrate. I really didn't leave myself much room here. So 1/2. Add 1 to that, you get u to the 3/2 divided by 3/2 or multiplied by 2/3. We should be getting to a place where we can make that switch now. That's 3 plus 1/2 times what? So, and I can factor 2/3 out. All right, so now it's just u to the 3/2. So 9 to the 3/2 minus 0 to the 3/2 because I factored my 2/3 out. So that's 3 plus 1/3 times 9 to the 3/2. So square root of 9 is 3. 3 to the 3rd is 27. 0 is just 0. 3 plus 9 is 12. 12, what are we even talking about here? Feet. That's the position. That's the solution for y of 5. Okay, find the total distance traveled. So this could be tricky because remember we have to say, okay, wait, when is v of t positive versus negative? So let's take a look from 4 to 5 seconds. So you need to think about v of t. Am I really going to sketch the graph? Well, not really, but I do want to figure out on this interval, like, what do I get when I plug in 4 and 5? And is the graph going to have any zeros in between? So we're looking on the interval 4 to 5. Okay. Let's set t times square root of t squared minus 16 equal to 0. What do we get for that? So we get t equals 0. That's one possibility, but that's out of our realm that we care about. What makes t squared minus 16 equal to 0? Plus or minus 4. So again, like minus 4, we don't care about. 4, we just found out is going to give us 0. Okay. So then what about the rest of this? So what would v of 5 be? is this positive or negative here? So v of 5 gives me 5 times the square root of 25 minus 16. So that's positive, right? This is a positive value. And anything in between is going to be positive, right? Say I pick 4.5. You're going to get 4.5 on the outside, and then a square root is always positive, right? If we're taking square roots of real numbers. So positive in between. So actually, total distance traveled is no different than my original integral. So the integral from 4 to 5 of t times square root of t squared minus 16 dt should be the same answer because v of t is greater than 0. It never dips negative on 4 to 5. So what did I get here? Without adding the 3, I got 1/3 times 27. So I got 9 feet. And I'm just using that part there without adding the 3 to it. Okay, that's going to end this video. There will be a next one for page 4.